Well, welcome guys again. So my name is Jaime Rosales.
And I'm Michael Beal, also with the Forge developer team.
And both of our Twitter handles are on the bottom, so feel free to follow, ask questions, give thumbs up if you like this webinar. And the reason of the webinar is to give you a little bit of information about what Autodesk Forge is and how it relates to the AAC industry today. So the title of viewing your 3D BIM data in the cloud, it's going to be the topic of today. So just a little bit of information before we get started. So I was giving a little bit of information about the AAC Hackathon. So it's going to be this upcoming weekend. So it starts on Friday, it's 5 p.m., a little bit of a mixer, doors open, hackathon kickoff, lighting rounds, and then they close at 10 p.m. So to start early at 9 p.m. on Saturday, same for Sunday. So come by, ask us about questions that you may have. And if you need help, please feel free to reach out. Don't be shy. All right, so now let's get started. So you probably joined, and some of you might know what Forge is. For those of you that do not know what Forge is, so Autodesk Forge, it's a new platform, a new initiative that we've been working with for a couple of years already. And it kind of like gets summarized into a set of like web service APIs in order to power this future of making things movement that we're heading over with Autodesk. So what an API is, for those of you who are not software developers, hopefully everybody is, it's a application programmable interface. So it's a lot of different services, endpoints in order to extract data and get and give power to those CAD models that we have and we're going to be using in the construction side. So a little bit more about it. So think about Forge like you have a let's say you have this container with different pieces. So a good analogy that I like to always refer to is think about it that you have a box of Legos. So a box of Legos that comes in with different pieces, different sizes, and individually they are one thing, but once you have a chance to put them together, you can create like an entire new solution, right? So you can create different infrastructures in order to just build on top of it and do integrations in order to help you with your day-to-day workflow. Forge itself, it's very focused into the data. So we know that we have data coming from different kinds of systems. So we have cost information systems, we have ERPs, we have construction management, we have design CAD. And if you think about it, we have a lot of different data coming in. So Forge itself, the initiative is to connect all this data in order to streamline those workflows and have them be beneficial for you. So if a little bit more into a visual explanation of what I just said. So Forge itself, when it comes to different workflows, so let's say viewing, planning, scheduling, this cost estimation, ERP, inspections, and so on, they all have different file formats. So I think there's 100+ different file formats today out there, CAD files. And not only Autodesk ones, we have other ones like CATIA, we have BTC Creo, SolidWorks, and so on, that if you think about it, you end up with a lot of different files with different file extensions that they do not talk to each other, and you miss out on the opportunity of transferring that data from one system to the other, right? So what Forge is trying to do is to connect all those different file formats and all those different workflows that you have into one. So we have different solutions within the platform, so different services that allow you to do this kind of workflow. And the first service that I'm going to mention today, it's the Model Derivative API. So what the Model Derivative API is, so we're going to start on the left side with our source file. So let's think about it. We have Revit, an AutoCAD, Navisworks, CATIA file, SketchUp. So any kind of source file, OBJ, STL, doesn't matter. And through let's say dropping this file into here, using our model derivative API service, we have 4 different outputs. Okay, so one of those outputs, it's gonna be the first one, an STL file. So STL files are used today for 3D printing. We have a chance to do OBJ files as well. So OBJ files, they are usually used today for like VR experience or AR experience, or even also 3D printing. But then we have a third extraction to a file translation, which is called an SBF. So an SBF, it's a proprietary format of the Autodesk Forge platform that will be used later on with our viewer technology, okay? So I'm gonna expand into the SBF and the viewer technology side of it a little bit more after I finish with this last 3. So the third one, it's an extraction of the thumbnails. So your source file contains different sizes of thumbnails in order to get a preview of what's the file that you're gonna be seeing. So I'm pretty sure if you have seen any kind of document management system, let's say Box, Google Drive, Dropbox, BIM 360 docs, so stuff that you might be familiar with, you are gonna be able to see a representation of a preview of the thumbnail of this source file. So the model derivative API allows you to do this kind of output as well. Later on, but let's say we wanna focus into a specific part of that source file. So let's say we have a Revit file and we wanna focus only on the walls of that source file. So we don't care about anything else that Revit file contains. We just care about the wall and the information of the wall. So we can do a geometry extraction that it's gonna give us back the parts of that Revit file that are containing and matches the criteria of a wall. So that's a geometry extraction. So you can do individual pieces of the model and be extracted and translated to be later on be used on the viewer. And the last one, but also very important, let's say you don't care about any of the viewable part, but what you care about is the data. So the model derivative also allows you to do a data extraction. So once you do that data extraction, you have access to basically all the information that comes in from that source file. So all that metadata that it's available in the original source file, you have a way to access it through the model derivative API. Okay, so moving forward, like I said, so you start with a source file, 60 plus different file formats, Siemens, STL, DWG, SolidWorks, so on. It goes into the model derivative engine. It translates, so gets metadata out and gets also the viewable out. And the Forge viewer, which is kind of like the eye candy technology, something that we love seeing, because the fact that we can load a full CAD model in our website without the need of installing any plugin or anything at all, it's actually pretty nice. But what you need in order to be able to use the viewer technology are one simple thing. So the browser that you choose needs to have a WebGL support. And if you don't know if the browser that you're using has a WebGL support, don't worry too much about it, because I'm pretty sure that if you recognize any of these 5 icons, they have WebGL support, and they had it for quite a couple of years already. So the Forge Viewer technology, it's based on WebGL, but more importantly, in also Three.js. So Three.js is a JavaScript library that allows you to render that 3D content on the web, okay? So I'm not too much of a slides guy, so I'm gonna take it on to showing you some demos of how this thing actually works. So this is just a preview of some of the demos that I'm gonna be showing you. So let's start with a pretty simple one. So if you joined earlier, I think you got a chance to see this. I had it just as a demo in the back. So basically this works as a thumbnail, as a gallery, sorry. So as you see here, I have 6 different thumbnails that I get extracted with the model derivative API. Let's say if I want to select my house model, now that it comes back, and let me know if you can still see the site that I'm showing you, because I'm assuming I can. Michael?
Yep, it's still showing. It's just showing
All right.
loading right now.
Yeah. I think because I had too many, let me just reload this. Too many tabs on it. Let's switch to this one. All right.
There we go. That's coming through.
Okay. So now, if you see at first glance, if you don't see all the loading process or anything like that, this kind of looks like some kind of gallery. You can see, oh, this is a picture on the top, but this is actually a full usable model already loaded on your site. We have a way to add different interactions to the viewer. So we can do some kind of rotation around the axis. We can do some exploding. And when I say exploding, let's see how fast this thing goes. You can break out the model into all the individual pieces of the geometry of this model itself. So it's something that it's running directly, like I said, on a site. I'm not having any kind of plugin install or anything like that. The other thing also is, like I said, this is not only a pretty picture. You can select parts of it and get access to metadata that it's pertaining to this model. So this is a Revit model, so it has a couple of information that are coming from it. So in this case, we're selecting a wall. If we select one part of the top roof, we also get different information about it. So pretty simple, pretty quick. And this is what we call a headless viewer. Headless, why? Because we don't have a toolbar that you're gonna see on the next demos. And also, if you are familiar with Autodesk products, we tend to have this navigation cube on the right side, top right, and you're gonna get to see that right now. So there's a way to use the viewer as a headless one, where you only focus on displaying the CAD data, the CAD model itself, and you can do custom-made extensions in order to interact with the viewer. Okay, so we're gonna move into another one. This is a sample where we have this nice looking Revit apartment, and then you have a way to also load multiple models at a time. So these thumbnails that I have on my left side are actually air conditioner units. So let's say I want to select one in this wall, and I want to add this one to it. We can also do some transformation to that second model that I just added by kind of moving it into a reposition of the different place. Then let's add another one. So a little bit more up. And then also let's add some floor unit. Let's say I want to have this one in that wall. So we're going to move it over here, move it over here, and then we're going to do some rotation on it. Okay. Then my translation, we're going to bring it up next to the wall. Okay. So now we have a model of a house with my included air conditioner units on it. And if you think about it, this could be expanded into like a full working application. Let's say we can add the air conditioner units to an entire building where we know the cost of energy that each model produces. We can do some data analysis and what's the cost of running this AC units through the span of, let's say, 1 year. Based on geolocation, you can know what's the weather like in that area. So in order to know which months of the year you're going to have this kind of AC units turned on for how much time and so on. So you can start seeing like a lot of applications for it already. We're going to move, I'm going to be closing tabs. So we're going to move into this one. So this one, it's as well the same kind of mentality of adding different models into the same scene. So I'm gonna select the point here, and I'm gonna add this one that looks kind of like a server rack. So I have my server rack here. And now I'm gonna start adding some servers into the left side of that one. So I'm gonna do it pretty quickly to add as many as I can. Let me know how the lagging is going.
Yeah, you got it about right there.
All right, cool. All right, so now we have quite a lot of different models in it. We can check how many do we have by just opening up the different list of the loaded models that are at the same time on the same scene. So let's say if we want to move one specifically, 80 degrees, and then we're going to translate this one and put it into this part here, and so on. So you kind of get the point that multiple models can be added into the same scene at the same time in order for you to do different interactions to it. And just bear in mind that this square box looking Revit fabric, I'm not a big like designer, so just don't judge. But this is a Revit file, and what I have here, this one actually came from Inventor, and this one is a Fusion file. So, and if you think that we're starting to connect that data, like there is no need to stay with one specific file format. The viewer, like I said, supports the SBF, and the model derivative can translate from 60 plus different file formats into the SBF. Okay, so moving along into some more advanced, let's skip this one for now, and let's go here. So this one, in order to do a little bit more advanced. So metadata, it's available from the model itself. You can see that we have, again, basic wall information, constraints, structural dimensions, and so on. But if you notice something, also we can inject metadata to the model. And we have here a database information. And this database information, it's coming from an external database, a non-SQL database. In this case, we're using MongoDB for this sample. So, and I can filter down by, let's say, material, all the supplier, and so on. So let's say if I want to see everything that it's steel in this model, I can select everything that it's steel, select on it, check the properties. I see the supplier actually is charging me one Brazilian something. Let's change that to something that I'm more familiar with. So we're gonna say it's charging me 100 per that piece of steel right there. So as you can see, also we're doing like some kind of cost breakdown on what the model itself can cost us. So based with the different kind of material database, we know that 92% of the entire building is gonna cost us around this amount of money. If we reduce that price, let's say to 10, we're gonna have a little bit more variety on it. So we can say everything that it's brick. Where's my brick? Right here. We're gonna do 100, but we're gonna do, say, euros, because someone in Europe is gonna sell me this brick. So now we see how the cost breakdown itself is starting to change, and also our graphical representation starts to change. So there is many things that you can do with the platform itself. And the only thing that it's Forge related, it's this left side, which is the viewer, where, like I said, you have access to the entire model browser of all the properties of the model. And on the right side, we have MongoDB database and some cost breakdown representation with some D3 graphs on the bottom part. We're gonna move into some of the demos, and I have preloaded ones. So this one, it's a wall analyzer. So you can see how we analyze per walls. Let me just move my GoToMeeting stuff. So let's say we want to focus on the 5th level, and I want to visualize only the walls on the 5th level. That's not a lot of walls, so let me try another one. All right, all the walls that are available on the 4th level. We can see all the walls that are available. We can do some wireframing in order to visualize this a bit better. Kind of track some points at some point if we want from the walls. We can also visualize the floor that it's pertaining to this level 4. So there's a lot of different things that you can do with it. So let's try to turn on maybe this 3 walls. So we have level 3, level 2, and level 4 available to be visualized on it. But if we want to get a little bit more fancy, let's see this one. Yeah. So this one also, again, same big model of a fabric where we can have a representation per category, material, or system type. So let's see everything that it's pertaining to the supply air of the building. We can visualize all this part. We can visualize also per material like we were showing before. Maybe there's a lot of material. Yes, that's what happened. So we can say, I want to see everything that is metal steel, everything that's copper. So we have a way to represent of all these different kinds of material. But at the same time also, if we want to focus, let's say, on specific levels, we can. So everything that it's pertaining to the level 14 of the building, or everything that it's pertaining to the level 10 of the building, we have a way to filter that with the access to the metadata of the model itself from the API. Okay, so let me close this. All right, so now some visual reports representation. So if you're familiar with Revit models, you know that we have an access to Revit 2D view sheets. And this Revit model, on the left side, we have the 3D representation of it. But on the right side, we have all the 2D views that are available. So in this case, we have access to the basement, the first floor, the terrace, the HVAC detail. So let's say we're gonna see the first floor. So first floor of the level of the model. We can select from this model itself, and we will see a highlight directly on the 3D model. We have again a way to do representation of the metadata with some different charts. So a bar chart for this matter, or a pie chart, same as we have showed you before. Let's see if we want to see all the HVAC. So let me hide this. One second. No, that's not what I wanted to do. All right. Hide selected piping. So now we can get a direct visualization of whatever I'm selecting on this 2D view. Okay. Let's move to another one. This one, it's representing 2D markups. So we can do view markups, and This is also showing kind of like a sequence demo of the different markups that can be added into the viewer. So we're gonna do some play on the conference room. So we start seeing some animations and then some highlighting of specific parts of the model. So a right chair, a table, the left chair, the bottom chair, and a top chair. Okay. So markups are available to be added to the viewer itself. And this is just accessing a lot of that Three.js functionality that we mentioned before. Okay, so IoT data also available to be seen and then represented with the 3D model. We have a way to, let's say, add some point clouds in order to represent different incoming data that it's based with the model. So we have temperature, acceleration, and lux that it's coming in and giving us that data available with it. We can switch to a different sensor where we're gonna have new kind of data. So you can start seeing already the application of kind of like constructing like a smart home or a smart building, where if you want to track specific data coming in from your sensors, you can have a visual representation using this technology in order to get access to it. All right, so now this one was built for a company that does Wi-Fi routers. So basically, we have a way to specify the source, let's say, of where the Wi-Fi router is going to be set up. So if you have a big house and you have set up Wi-Fi routers in the past, you know that the signal kind of gets lost through the space based on, let's say, hitting walls or the height of wherever you place it. So we're going to place one here. And we're going to see what's going to be our like soft and hard spots in order to get better signal. So this one kind of gets a good amount of signal wherever it's not colliding with a wall. This signal attenuation per wall can be adjusted. So you see how it's actually starting to reduce. And then we can also do some kind of dynamic mode. So instead of pressing it every time, we can start like kind of like just moving around the entire model in order to get a different visualization of what's going to be our best spot in order to place that router that we're trying to set up. Okay, let's close this one. Different animations using camera Tween library. This is basically just to do some kind of like demo with a lot more. I don't know how this animation looks on your side. Might be a little bit choppy.
Yeah, it's a little bit choppy.
That's what I thought.
Yeah, so maybe reducing the window might help.
Yeah, so I think I'm gonna stop it because
yeah,
I think you can see it better in the recording because I don't want to get too dizzy. Okay, so now another thing that I found pretty interesting for the use and application with the AAC industry. So like I said, all this metadata is available. You have a way to access different parts of the model, information about all this geometry itself. But the cool thing about it is that there's a way also to do an exportation of that metadata, let's say, into an Excel spreadsheet. So we can do an export to Excel, starts reading the project information and prepares the apartment furnished Revit Excel file. And then at some point, I'm gonna get a download of that Excel file. And if this doesn't work, I can blame Michael because actually Michael worked on it.
That's true. You can blame me on this one. Oh, you know, you might not have Excel installed.
No, I do have.
I'm just kidding.
All right. So while we wait for that thing to come, I'm going to show you another one. This one, it's a visual reports representation as well, but my data, it's coming in from different file storage systems. So in this case, if you're familiar with BIM 360 Docs, I'm reading into my account of BIM 360 Docs, my project of BIM 360 Docs, and the different folders that I have in it. So I can launch my 2D, 3D representation. And if you've been playing with the technology for a couple of years, you probably have seen something very similar. One of our like rockstar engineers in Autodesk actually built this sample, and you have again the same representation of like highlighting from the 2D to the 3D, accessing all the different view sheets and the representation of different parts of the model itself. You can sort it out, let's say, by level. So if you want to see everything that is pertaining to the first floor, you can, and so on. But the cool thing about this one is that it's coming in from a different file storage system. So let's say if you have Google Drive, you can connect this to Google Drive and have everything in all your models coming in from here. All right, so Michael, what happened with that thing? Let's see.
Maybe it's ready for file.
Probably, yeah.
Handy.
All right, that's fine. Okay, so let's close this one, close this one. This one I show you. This one I show you. Okay, so now, and also the viewer itself has a good way to interact with WebVR. So if you want to try right now, if you have your phone somewhere close, so you can scan this. Let me refresh this 1 second. Yeah, so you can scan this QR code, and we're gonna start this model.
So you're going to be the presenter, and I'll use my phone, and I'll scan this QR code.
Yeah, and you can tell me if it works because other people.
Yeah, I've got a little iPhone 6S here, and when I scan the QR code with the camera, I get to see this house model that you've got. It says a button comes up that says connect,
So
and I
connect to it.
Connect to your session, and now on my phone I can see this split screen view for Google Cardboard, so I can see this house on my little phone screen in split view, left and right yeah. eye. I stick that in Google Cardboard, and I can see this view. Okay, so now what? Now what happens?
All right, so now if anyone else tried other than Michael, you're gonna be able to see what I'm starting to do interactions with the model right now. So let's say like exploding this, you're gonna see that kind of explosion happening in your mobile device at the same time.
Right, so I can look around the scene now. When I turn my head around, it's moving the house around, and I can see it's someone's exploding it. So I guess that's you.
Yes.
Got it. So you're giving me a sort of a tour guide of this building.
Yes, correct. So if we want to do a section analysis from the top, you can see the inside of the model.
Yeah, I can see the first floor now. It's being sectioned.
Okay, so hopefully people was able to give it a shot and try that. You guys can tell me after. And because I show you this starting with like WebVR representation, I'm gonna continue with the slides and hand it over to Michael.
Awesome, thank you very much, Jaime. So you're sort of continuing on that idea of, what Forge can provide in the sort of web AR and web VR space. I'll sort of continue on with what we've been up to recently. So we built this thing called what we call the Forge ARVR Toolkit, and the idea behind it is we traditionally have been supporting VR initiatives using the browser through the web VR spec, and that's been great. That's leveraging the web platform. But we noticed that the the AR and VR community have been using other platforms. And Forge, while working with the web platform, we figured it would be a good idea to also support some other platforms. And so what this Forge ARVR toolkit is about, it's something that we're providing so that Forge can support these other platforms, such as Unity and Unreal and maybe other platforms. But we're starting with the Unity platform to get started. That seems to be a really good community that's vibrant, and it's doing a lot of great things in this AR and VR space. So how does this sort of work? So think of it just like you've seen already with the existing web platform, so with the browser, and the same workflow applies. You've got 60 different file formats to work with. Say you've got a SolidWorks file or maybe a Navisworks file, and it's in an NWD format. You use the Forge RESTful services to send it up through to the Forge model derivative service and through the APIs, and that service then converts that Navisworks file or SolidWorks file into a normalized format, which is currently being decoded and viewed in WebGL in a browser. That same normalized format, we wrote a special plugin for Unity that can also decode that format. And that's what we call essentially the ARVR toolkit. And we provide it as open source C# code on a GitHub repo. But it's still in a beta form, so it's still a little bit rough around the edges. And we've been signing people up on a beta site, and we're about to release a website that you can access the same information without having to sign up. So it's going to be available through GitHub. So in this diagram, you can see my Navisworks file gets translated, and it then gets pulled into something like the Unity platform. And then from Unity, I can export this and make it run on a HoloLens, or in another device, which is pretty popular. A cheaper device is Apple's ARKit and an Apple iPad. So I guess flipping to the next slide here, let's see if that works. So what's sort of achievable with this? We've got a couple of AR demos going on this page that sort of show you how you can get your existing, Autodesk red car, and you can use a HoloLens to visualize that in front of you. Or maybe you want to section a building and show that visualization in front of you, so you can section it with your hand gestures or maybe some controllers. And in the sample code that we've got for HoloLens, for example, it can detect something like a QR code, and then once it has the QR code, it authenticates with the Forge toolkit, with the Forge services, and it pulls down those meshes and loads them inside the HoloLens on the fly. The toolkit also has a number of other features. So it's not just runtime loading of meshes. It also has the ability to load those meshes to be used statically and offline. So for example, I wanted to view this car on a HoloLens, but when I take the HoloLens somewhere, it doesn't have Wi-Fi. So I can pull those meshes and pull them into Unity as an asset bundle and deploy it as a HoloLens application containing all of that mesh information. A couple of other useful features that the toolkit provides that doesn't exist yet in the web platform is this concept of bounding box spatial queries. So when I'm going to go and section a building, like you can see the building in the bottom left corner there, I want to just load something like maybe the first floor of a skyscraper inside a HoloLens. I don't want to pull all of that mesh information for the skyscraper just to see the first floor. So the toolkit provides an API for you to do a spatial query to limit the region of which is down to it just loads the first floor meshes. And that's what we call a bounding box spatial query. Another query which could be useful is in the top right-hand corner. You can see another building there. And I just want to visualize just the structure of the building. I don't need to see the facade or the desks and chairs. And so we also provide an API to do a string-based query or a tag. So I'm only going to load meshes that are based on metadata, in this case, on a metadata specifically around building structure. So if I flip to the next slide, this gives your workers this kind of visualization. This is sort of an example of what we hope, our developers, our customers can build. They can use Unity to build this sort of data visualization where they can augment the content from Autodesk, such as this interior of a factory, and augment information from their own databases, such as maybe this graph that's sort of a heads-up display. And that comes from, say, the heat from a pipe, from an IoT sensor. And you want to be able to visualize that in this 3D scene using a HoloLens or maybe Apple's AR kit. And it provides a richer experience for a worker where they don't have to navigate around a 3D model and slice it to get to this particular scene. And they can see everything in context. It makes things much more efficient for spatial challenged areas. And it means there's going to be less work for a worker to go back to some, central Excel spreadsheet somewhere on a desktop computer. It means they have everything in front of them overlaid inside the space. And that's kind of what we're all, we're noticing a lot of small businesses are starting to, they're starting to look at those sorts of ideas. So one example of that, one recent example of that was last year at Autodesk University. We teamed up with a company called Connects, and we came up with a website, and we worked with them to use this new ARVR toolkit in a new kind of way. They wanted to rethink how the job site could be used with augmented reality and a commodity device like the iPad. So just imagine, in a collaborative way. So just imagine you've got 4 or 5 users running around with iPads on this structure, and they're maybe doing an inspection task where they walk around the site, the construction site, and they're looking for maybe some flaws in the building. So for example, a rusty nail or something that's a little bit hard to see. So we created this app on an iPad using Unity and the Toolkit to allow them to mark up this building and feed it back into their issue tracking database. So they could add RFIs and issues and any sort of hazard information. So here's a video I'm displaying right now, and it shows the app in progress. In front of us is the actual building, this little Connects structure, and Merton here is using the QR code to calibrate the position, and then we can overlay the 3D model, the actual 3D model that comes from Revit, from Navisworks, and then we can start adding these virtual sticky notes to the building. And those virtual sticky notes then get fed back into a central database, which you can see if you go to the vrock.it website. You can see that you can actually see those markings, those virtual sticky notes appear in a WebGL browser. So you can see that it's being all this metadata is being central. All this 3D position metadata is being centralized in a central place. Some of the other things that we wanted to do with this proof of concept was to also visualize what the third and extra level would look like. It plays later in that video, but essentially you can also visualize what a future building will look like using augmented reality and the iPad AR kit. So that's pretty much it for the sort of customer example of somebody using that toolkit. We've got a number of other examples, but the place to start using the new AR/VR toolkit with Unity is on this website. And if you go to forgetoolkit.com, that's the place to get started. And I think from that, I'm going to hand it back to you, Jaime.
All right, cool. Thank you, Michael. So just one more, I guess, customer sample. We have this company, Dodie. They're based in Australia, and they've been doing quite a couple of like cool things also with AR and the use of Forge for quite some time already. So something that you guys can check out, it's their app. So it's available in the App Store and also Google Play Store in order to do some Dodie AR functionality. So you can load something like this house, for example, and then being able to look at it through using the AR kit that the Apple device has, for example. So something cool to take a look at it. Then we're close to the end of this, but I wanted to give you some point out. So I know some of you will be at the hackathon, and if you are looking in order to start with the use of Forge, we are currently working on a new set of tutorials that I'm just quickly gonna show you. So if you guys are interested in it, I'm gonna add all the links that I showed to one of the slides of this presentation. So I will send also the link to the slides, and that way you guys can look at it after. But it's a new.
I mean, also probably if you can add, we'll add those links, the demo links to the blog site as well. I think I mentioned
that. So and then the new things that we're working on is just to make it a lot easier for you guys to get started with the technology. So it's still in very like draft mode, but we've been testing it, and so far it's working quite well. So I invite you to guys take a look at it, and it takes you through the steps of what's the setup that you need in order to start from absolutely zero up to having your model available in your own repository, in your own buckets, in order to be able to visualize them with the viewer. So it takes you through the part of creating your Forge account, activating your subscription. This is free to use for the trial period. I think it's 365 days for the trial period. So you guys are welcome to give it a shot. Then it takes you to the steps to create an app. And then so far, we're planning to support many different languages. So Ruby, Python, Java, Go, and so on. At the moment, we only have Node.js and .NET. But let's say if we decide to go to the Node.js route, it tells you also if you don't have an available IDE, you can get the Visual Studio Code IDE. This tutorial is actually based using that kind of IDE. But if you're familiar with any of the other ones like WebStorm, Sublime, Atom, and so on, feel free to use that. Later on, takes you through the authentication process. So two-legged, three-legged, teaches you about scopes and what are the different scopes that you need in order to have your token with the right permissions in order to create buckets, upload files to bucket, translate your files, be able to view them. And then you're gonna end up at the end of the tutorial, which kind of drives you through this process with something that is gonna look like this. So I do have this running already. So if I click on one that I previously uploaded, you're gonna end up with a site that looks like this, which you can later on, let's say, deploy into like a free service such as Heroku. And you're gonna have a link available already in order for you to visualize this. So that's the kind of like the endpoint of this tutorial. You are able to create your bucket. So webinar test. So we create a bucket called webinar test. We can upload a file to this bucket. So let's see. What do I have here? Let's do this engine OBJ. Not very AAC focus, I know, but So now if I click on it, it tells you that this file is not translated yet. So you can either do a right click and translate. Yeah. Or click the start translation. So the translation started. So just please try again in a moment. If we click again on it, it's going to tell you that the translation job process is still running. So it's at 0% complete. And if we give it just a couple more minutes, this shouldn't be too big, I think. So it should load you the file already. So it's pretty simple to start. All the steps have been defined to create the server side of it with either Node.js or .NET. And then the show viewer, since like I said at the beginning, the viewer itself, it's a JavaScript technology. So it has all the steps with HTML5 and JavaScript on it. Okay, so I think that's it for us. Well, documentation, you guys can head over to developer.autodesk.com, where you can find out about the different solutions. So data management, design automation, which is basically a service that runs scripts on your design file. So let's say all the services from AutoCAD can be run directly on the cloud without you having installed AutoCAD in your computer. So this could be run as a service. The model derivative in viewer, which is the one that we talked the most about. Reality capture, that it's photogrammetry technology. So you can create 3D models out of orthographic photos or laser scans. The BIM 360 service that allows you to do custom integrations with the BIM 360 family of services. So BIM 360 Team and BIM 360 Docs for now. And a beta one that's webhooks. So in order to get notifications about the different Autodesk web services. So if you are reading from a Revit file from a specific location and then something gets updated in that Revit file, you will get a notification when using the webhooks API. Okay. And then code repos, we have, sorry for the sirens, I'm in New York City, so
you must be in New York.
Often. Yes. So GitHub, we have our repo Autodesk Forge, where you can find out about many different samples that we have done and worked on. So for example, the first one that I show you with the headless viewer, it's hosted here. So all the code is available for you guys to grab and use. Blog post. So you can head over to forge.autodesk.com/blog. And I see that Michael already published something about the webinar that you guys are watching right now. And if you want to get help, the simplest thing to do will be we use Stack Overflow for our support. So you can either search for a question on the viewer. So let's say to the viewer, and then you can select which API. So viewer, you do a quick search, and then you're going to get different hits on the Autodesk viewer or Autodesk Forge tag on it. And if you don't find your question on it, you are free to ask a question. So ask a question, making sure that we have either the Autodesk viewer one or the Autodesk Forge tag on it in order for us to get notified about a new question that you guys have sent to us. Okay? So, well, thank you guys again for listening in. Hopefully this was helpful. So I'll catch you guys next time.